Now remember, what does it mean for two expressions to be algebraically equivalent? We just have to prove that one side is equal to the other side, and that doesn't necessarily mean finding a numerical solution. One way we can do this is by using our commutative, associative, and distributive properties. So let's take this basic example. We have 2x squared plus 4x equals 2 times x squared plus 2x. Well, I'm just going to bring this down. Let's try working with this first. Well, I see that we have a 2 and we have a polynomial in parentheses. Why don't I try distributing it? And I'll write I did the distributive property. 2 times x squared is 2x squared. 2 times 2x is 4x. Well, what do you know? Both sides show the same thing. And I just proved it using the distributive property. The other thing you need to know, if we were to plug in numbers, any number would work. So therefore our solution set is all real numbers. Let's look at another problem, but this time it's going to have multiple properties. So we have the same 2x squared plus 4x, which we can bring down for our next step. We'll keep this the same. Now, we have the distributive property again. 2 times 2x is 4x, and x times 2x is 2x squared. That's distributive. But we're not done yet. These both contain the same 4x and 2x squared, but this is in the reverse order. What do we need to do when reversing an order? Commutative property. 2x squared plus 4x, and it's the commutative property of addition, because we're dealing with an addition sign. 2x squared plus 4x. And now it represents the same equation. And we also would write commutative property. And that would be our proof. 2x squared plus 4x equals 2x squared plus 4x represents a set of all real numbers, and we prove it by using the distributive property and the commutative property.